Today, we are not going to talk about syntax. We are going to talk about how to design communication in Angular properly. Because here's the naked truth. Most Angular problems are not coding problems. They are state design problems. If you design state correctly, communication becomes trivial. If you don't, you end up with event flying everywhere, components tightly coupled, debugging nightmares. Every communication problem you will face in Angular usually falls into one of these categories: parent to child, or child to parent, or sibling to sibling, or shared or global state. If you understand these four patterns, you understand Angular component communication. But there is a problem with thinking about communication only this way. It focuses on the movement of data instead of ownership of state. When you think of it in terms of parent sends data to child, or child sends data back to the parent, you often end up designing a system where components are constantly pushing data around. Now that usually leads to, number one, too many events, number two, tight coupling, number three, data flow that is hard to follow. In Angular changes how we think about this. The real question is no longer how do I send data between components, but it's about where should the state live and who should react to it. Let me repeat again. We do not move data around. We expose state and component react to it. All right, let's start simple. Before we talk about modern Angular, I want us to begin with something familiar. In traditional Angular way, the parent component owns some state, as shown you with this declaration here of count. Then the parent passes the value down to the child. In the child component, we receive it like this: use and add input, our property name, and our type. So far, this is normal Angular. The parent is data, the child receives data. That is parent to child communication. Now, what is really happening here? In the traditional Angular model, parent pushes value down into the child, and the child receives the value as plain property. So, inside the child, the value is just a property on a class. But here's the part we do not always talk about. If that value changes, Angular will run change detections. Yes. But if the child needs to react to that change with extra logic, you usually have to handle it yourself. For example, you will end up using ng on change lifecycle hook, or you might use an input setter. Let's be clear here. This works. This is still valid in Angular, and many applications still use this approach. But the important thing to understand is this: the old add input approach gives the child a value. It does not, by itself, give the child a reactive model for that value. So you receive data first, and then you decide how to react. That is the old Mendel model. Let's look at the same idea in modern Angular. In the parent, instead of using normal number, we are going to use a signal. Let's call it count. Then in the child, instead of using add input, we will use modern input API, input.required. At first glance, this looks almost the same. The parent still owns the state, the child still receives something from the parent, but the mental model is different, and this is the key point. The child is not just receiving a plain value like what we saw earlier on. The child is receiving a reactive input signal. That means inside the child, we do not read it like this dot value, but we read it as follows: this dot value accompanied by brackets. And that matters because now the child can react to this input as part of Angular signal system. We talked about signal in our videos. Okay, so if the parent updates the count signal, Angular updates the child input. And anything in the child that depends on our this dot value can automatically be updated. For example, if we have got a computed or a derived signal, it gets to be updated automatically. This means that there is no ng on change life cycle hook, no setters, no manual syncing, no extra logic to keep the derived value up to date. So instead of the old flow where we receive data and then react to it manually, we now have this new model where we receive read reactive state and Angular updates dependency automatically. This is a major shift if we are to compare the two, that is the old model and the new model, using different concepts like type, reactive, change, handling, mental model, and the best for. You can actually see the difference which are there between these two here. Think of it like electricity. In the old model, the parent gives the child power, but if something changes, the child often has to check what happened and decide what to update. But in the modern model, the system is wired reactively. When power changes, anything connected to it updates automatically. That is what Signal gives us. But I want to be very careful here. This does not mean that the old way is wrong, that is using the at input. It still works and it's still valid. And in very simple cases, it can still be perfectly fine. But in the modern approach, it gives you some real benefits, like less boilerplate, less manual syncing, more predictable reactivity, a cleaner mental model, better scalability as components grow. So here is the line I want you to remember. The old model gives you data. The new model gives you a reactive behavior.